Today we will discuss some points on electricity. Electricity. See, electricity means there is a current. Okay. So it may be flowing or it is in rest. So two chances are there. So current may be flowing if the potential difference occurs. If there is no potential difference, it may be in rest. So that's why. So electricity means we can say that this is nothing but charge. Correct, na? Charge. Again, charge means again. So you will notice that one positive charge and one other one is negative charge. So negative charge means we know that they are electrons. They are electrons. Okay. So positive charge means they are protons. Correct, na? So electrons means it is 1.6 into 10 to the power of minus 19 coulomb. Okay, na? So this we have in our textbook. Okay. So that means electricity means there is a charge. So if it is in rest, that is called static electricity. Static electricity. Suppose if it is moving, okay, that is called current electricity. Current electricity. Okay. So if the charge is at rest, it is called static electricity. Suppose charges are moving. It is called current electricity. Okay. So now we are having moving current. So that means we have to come this side. We don't want this. This is also one part, but we want current electricity. Okay. So that means, so what is current electricity? Flow of charge in a closed circuit. In a closed circuit. Okay. So that means again it is a directional flow of positive charge in the direction of flow of electrons. Okay, in a given circuit. Okay, that means charges are moving. So in this, again, it creates 2 points. So one is electric current. electric current, that is I. So next one is electric potential. Electric potential, electric potential. Okay. So electric potential means we indicates that this is V, and current means we indicate that it is I. So that means how we are measuring electric current? Okay, it is measured by current is measured by ammeter. So it is measured by ammeter. That means 1 amp is equal to 1 coulomb per 1 second. Okay, that means it is equal to I is equal to Q by T. Correct, na? This is also one of the important question. So now we will come to electric potential. So electric potential means V. So V is equal to, how we will get? V2 minus V1. If you take the potential difference between 2 points, you mark one line or one wire, you mark 2 points. You want V, this is V1, this is V2. If we want V, so we have to minus these two. Then we will get the voltage. Now, see, this is current. How we will measure? So SI unit for current. Current is ampere. So this is also important. Okay, now we will come to this side. How we will measure voltage? So 1 volt is equal to 1 joule per 1 second. That means, so okay, this is enough. V is equal to J by C. So it is measured by voltmeter. It is measured by voltmeter. SI unit is volt. SI unit is volt. This is also important. Okay, now one side we got electric current, other side due to flow of charges, so we got electric current, other side electric potential. So this is the relation between, this is the relation of Ohm's law. Correct, na? This is Ohm's law. So Ohm's law, what it is telling? V is directly proportional to I, or I is directly proportional to V. Both are same, but the condition is at constant temperature. So at constant temperature. Suppose V is equal to, if you replace proportional symbol, you will get Ri. So Ri means what? Rate of, it is a rate of V by I is constant. If you plot the values, so that means R is equal to V by I, it is a constant. So you can see this graph. So this is V by I, so it is constant. Okay, now we will speak about resistance. Now resistance came into picture. Resistance. So for resistance, the SI unit of resistance is ohm. Correct, na? So that means R is equal to V by I. This you keep it in mind. Okay, this is constant. So the SI unit for resistance is ohm. So like this, like that you can write. Now resistance came to picture. Now what we have to do? Resistance may be connected in series or parallel. Okay. Now series means you take two resistances and connect in series, R1, R2. Okay. So what is the condition here? Current is same. Current is same throughout the circuit. So this is the condition. That means I is equal to I. Current is same. No difference. But what is the difference you will see here? The difference in potential. Difference in potential across in different resistors. So this difference you will see. Okay. So that means V is equal to V1 plus V2. This is the condition for series connections. Now what about parallel connection? So in parallel connection, current is different. Current is different in different resistors. Okay. So that means what? I is equal to I1 plus I2 plus I3. This is the condition. Now then, what is this same property? The same property is the potential difference. Potential difference in each resistor in resistor is same. That means V is equal to V. Okay. Now we will discuss equations on both sides. So that is equivalent resistance. Here equivalent resistance R is equivalent resistance is Rs is equal to R1 plus R2. This is very important equation for series connection. Now we will come to parallel connection. So here the equivalent resistance is 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2. Okay. If you simplify this, you will get 1 divided by Rp is equal to R1 plus R2 divided by R1 R2. Still, if you want to simplify this, Rp is equal to R1 plus R2. No, this is R1 R2 divided by R1 plus R2. This is still further simplified equation for parallel connection. So now this part is over, series connection and parallel connection. So we are talking about resistance, correct na? Now we will extend this. So that means still we have not discussed some properties of resistance. So next slide we will go. Now it will extend from first point is Rs, second point is Rp. Now the third point is rho, resistivity. So that means what? Resistivity means it opposes. That means any conductor it opposes the flow of current through the conductor. So that means it depends on, rho is depends on length of the conductor. That means R is directly proportional to L. Number one condition. Number two, area cross section. It is so area of cross section. area cross section. That means resistance are directly proportional to L and inversely proportional to A. So this, if you remove, R is equal to rho into L divided by A. If you separate this rho, you will get RA divided by L. See? So rho is, resistance is directly proportional to A and inversely proportional to L. Oh, this somewhere we have made a mistake. L by A. So if we keep this here, so L will go down. No, just you see here, rho you keep there. So that means RA. So this cross multiply this, RA divided by L. Hey, correct. It is correct. Okay. RA divided by L. So this rho is, or this rho is, it is a constant. It is constant. Is known as resistivity. So for SI unit of this resistivity, SI unit of resistivity, SI unit of resistivity is ohm meter. So by seeing this, you can tell that if the conductor has low resistance, then we can say that it is a good conductor. It is a good conductor. Suppose it is having a conductor having a high resistance, we can say that the conductor has a bad conductor or insulator. Now suppose this rho gives, suppose it is having high resistance, what will happen? Temperature of the conductor will rise. High rho means temperature will rise. Temperature will increase. Temperature will increase. So next, the nature of the material we are using. The nature of the material we are using. Correct na? It may be a may be a aluminum, copper, iron or alloy, etc. Any conductor we can use. Now, suppose temperature is rising. That means more resistivity. We are using a conductor, it is having a more resistivity. What benefit you will get? That means you will get a heating effect. Heating effect of resistance. Resistance is more. Okay. So this is known as, this is known as effect of heating effect of electric current. Okay, now you got some idea. Okay, so now suppose temperature is rising of a conductor. Again here two parts. Why the conductor is getting heat, or why it is getting of hot? Because part of the energy is used for full work, used for useful work. And what about other part? So other part of the energy is used for heating the electronic gadgets. See, due to this resistivity, some part of energy is used for useful work, and remaining part it is used for heating the electronic gadgets. Now again here one more equation will generate. So H is equal to V into I into T. Okay, V into I into T. Now we will see here V is equal to Ri. So here we can write V is equal to Ri. Correct, na? That means Ohm's law. Okay. So that means just I am putting some star marks. Just you compare. Now again the SI unit of heat is joule. Correct, na? So this how we can write? this how we can write? H is equal to I square R into T. So this is called Joule's law of heating. This is called Joule's law of heating. Just I am putting 2 star here. You compare this. Okay. Now second part will come. Second part, some part we are using useful work. See, here using alloys. Where we are using alloys? Electric heater. It is continuous actually. Electric heater or electric iron. So okay. So for this, how we will give equation? P is equal to V into Q by T. So that is equal to V into I. I will put this one single mark. Now we will go back. Current, you see, here I am putting. See, already star mark is there. Just you compare this. Okay. So this is power of a resistance. So that means P is equal to V into I. Power, how we will measure? Power, how we will measure? In terms of watt. That means this is the SI unit. So just one line you make it. SI unit of electric power is watt. Suppose you are not using small current. If you are using a larger current, that's why instead of measuring watt, you can measure it as a kilowatt. Okay.